All right. All right. Let me get mine shared out here. All right. Welcome everyone today. As was just mentioned, this will be a little session on automating penetration testing with Bash. First and foremost, let me go ahead and throw a little bit out there as to what this presentation is and isn't. I'm going to go over it more later on, but I'm not going to be giving you any like massive world breaking, like this is a cutting edge script here that's going to go out and hack the Pentagon or something. We're not doing that today. It's just going over my experience with some of the little tips, tricks, things that you might not have considered, things of that nature, as it pertains to scripting up some of your day-to-day activities, some of your automation concepts that you want to do for penetration testing in Bash. I've been a system administrator on Linux systems in the past, and I've used Bash to help automate various different activities and processes on there. Same thing applies to doing any other activity such as penetration testing. If in fact you're using a system that uses Bash, then you can do this. But yeah, we're going to get into that here in a minute. So we're going to be covering a little bit, well, not a lot, some basic concepts of Bash, and then step way up a little bit about some gotchas and things that I've noticed about over time. But yeah, let's go ahead and get started here. And if I can get my mouse to work, my apologies on that. So first of all, this does assume that you have some familiarity with Bash. General concepts around like what Bash is. It is a shell environment, much like ZSH or SH or Dash or any number of other ones you may encounter on a Unix system. Reason I'm going with Bash is that it is pretty much everywhere, but you also need to be understanding of some basic Linux or Unix concepts such as pipes and other commands like sed and awk and cat, things like that might come in handy as part of an automation process. And standard scripting terminology such as a loop or an input and output, things of that nature. Not very complex terms in general, but you got to have at least a little bit of understanding before we move on. Ideally, everybody's going to have that if you're interested in this in the least anyway, so no big issue on that. Excuse me. So what exactly is Bash and why should I care about using it to do some automation and whatnot? Bash stands for Bourne Again Shell. It is a successor or a follow-on to the old the shell environment, SH. It took that, which was POSIX compliant, and then added a few extra features to it, such as arrays and a bunch of other little things that's added to it over time now. I think it's up to Bash version 5 dot something now. But yes, I think I could be off on that. But it is just a shell environment, much like any others. ZSH is probably one a lot of y'all are familiar with now because it's showing up more so on a lot of newer distros as well as it's on on Mac OS. But Bash is the one that I'm most familiar with. I've been doing scripting and coding in some form of SH or Bash since before 2000 sometime. I forget exactly what year it was, but I've been doing this for a while. So I'm old, I'm gray, I'm stuck in my ways, so I still want to use Bash. Why else use Bash? While it may not be the default on every OS anymore, because like OS X, it is still installed by default on a vast majority of all your Unix systems that you're going to encounter out there. If you do like Windows subsystem for Windows subsystem for Linux, things of that nature, you'll get Bash. OS X does have, or Mac OS, I should say. I keep saying OS X. That dates me as well there. I apologize. But Mac OS does use Bash as well. It defaults to ZSH, but you can easily run Bash as well. And most Bash scripts will run in ZSH as well anyway. And it does come with it is a scripting language as well. So a lot of different functionality you can do in there to do sort of automation approaches. What can't it do, or what shouldn't you use it for? It's not a general purpose programming language, even though there's those of us who like to try to program anything we can in Bash. I've seen people do full on music jukeboxes written purely in Bash. I've seen databases, all kind of things written in Bash. Not to say that you should, but you can. It's just not the best approach to use for that. It's great for automation, system maintenance, stuff like that. But when it comes to things that are very GUI intensive or memory intensive, things of that nature, Bash might not be your go-to choice there, or any shell environment, really, for that matter. Additionally, error handling is fine in the way that you can set traps for like SIGINT or SIGTERM and SIGHUP and things of that nature. And you can have standard out and standard error, but built-in functionality to handling errors and logging and all that is really non-existent for the most part in comparison to other languages like Golang or Python or Ruby or what have you. So it boils down to it is a scripting language for its purpose, and it can be made to do lots of other things, including pseudo object-oriented programming. For those of you who want a challenge, go try that. But that's really not where its strong point is. And we'll go through some of its strong points as we're working through this. So where can you find Bash? As I said before, pretty much anywhere that has a Linux system on it. Linux, Unix, all pretty much at this point have a version of Bash on there. macOS does as well. They have recently shifted to ZSH, Windows Subsystem for Linux, Git Bash, Cygwin, a number of embedded devices all have Bash on them, or some version of Bash. Might be in a slightly older version, like macOS comes with a version 3.4 or something like that. It's nowhere near the most recent version of Bash, but it still has a lot of the capabilities. There might be a few tweaks in there that are missing, but you do have the basic functionality, and depending on what complexity you're using, it should work across the board. All right. Step through this a little bit. I'm taking up too much time talking about the history of it. I think the next slide we actually get into some code. But so why do Bash scripting for automation? Well, it already exists on the OS. For most part, you can have you can pipe commands in and out. It's easy interaction with commands, output, the exit code that comes back from them. You can do a number of different things in there. You can store the output as variables. It's a lot of low-level or system-level operations you can do inside of an OS or inside of a scripting language that isn't as intuitive in some other languages. And why use it for penetration testing? Same reason you'd use it for any other automated tasking, is that just save yourself some time. Go through there. It helps things stay organized. If you're doing a repetitive set of tasks or you're wanting to trigger off certain conditions, having it already set up to do those triggers for you, one, it saves you some time, some headache. You can have it ensure consistency because it's running it the same way every time. And while I did say before it's not the greatest on logging, you can add logging to it via various functions and whatnot, or have it just pipe out to files or use the T command, anything like that. And by having it automated via something like Bash, that helps you be consistent on your logging as well. Because I don't know how many times during an engagement I need to go back and get a screenshot of some output or something, and I don't have it anymore because I didn't save the output, or I didn't tee it out to a file, or what have you, or I didn't set up logging in my screen session. Having it already baked into whatever functionality or scripting that you're using is great for that. I do see I have one comment here. How do you know when you've gone too far and should move what you're doing to another one? Okay. When the question is how do you know when you've gone too far and trying to program something in Bash that should be moved to a more powerful language? And really, that's up to your own determination ultimately. But in my general gut answer would be, if you find yourself having to recreate functionality that you know already exists in another scripting language or another programming language just to get a simple task done, maybe it's time to move over to that more complex language. If all you're trying to do is, say, I don't know, do some simple task that you're going to be doing a lot of time, and you're trying to do that in Bash, and it's taking you a couple of days to write it up, test it, and all that. When it's a simple command line or a simple function call in another language, maybe it's time to take a look and see if you should move everything over to that other language. But ultimately, you're the programmer, you're the scripter, you're the one who has to make that determination, how much pain and suffering you're willing to put yourself through. Like I said, I've done pseudo object-oriented programming in Bash. I've seen people do full jukeboxes in it. They've done all kind of amazing things in Bash. So if you want willing to put in the time and effort, you can do some amazing things if you're willing to suffer through it all. Honestly, once you get to that level, most of your common tasks, no suffering involved. Really simple. For example, world's simplest script. You have to do the hello world. In Bash, it's just the straight up echo hello world. To be a complete Bash script, you have to have the shebang at the top. That is that hash sign, exclamation point. That's called shebang. That tells it what kind of script this is. The first example there is what you more commonly will see. It's where somebody just says /bin/bash. That says this is going to be running bash and it's located in bin bash. Run the rest of the code here via that interpreter or via that shell. The second option is more in line with what I typically write and what I see a lot of other Bash developers doing now. And it's that because Bash may be installed in a different location or it might have different versions installed. This way, if you're using user bin env, what that does is it's a command in Linux or in Unix that says find what the current proper version of the following argument is and run that. So here I'm saying find the current proper version of Bash and run the rest of this through that version. This is handy on things like macOS, where if you install an updated version of Bash via like brew or something like that, or homebrew, it installs it in some weird path, not bin bash. And this way you can make sure it's pulling the proper one and things of that nature. It's just a little more consistency across the board in case things get moved around. I've seen people move it to user bin bash if on older systems, things of that nature. So doing the user bin env is just one little thing that might help you out down the road. Oh, also, before these will actually run from the command line, you probably want to make them executable on most Linux systems, all Linux systems. It's a chmod plus X, and then the file that will make the file executable. So you should be able to run it then. So the things that you might need to worry about if you're writing an automation script, as I said before, the shebang, that's the part at the top that tells you what the interpreter is, what variables are, what functions are, what loops are, and file IO. All standard things that hopefully you have some understanding of by the time you've got to here. If not, I can possibly throw you some links that gives you some intro to scripting and programming and concepts, but a variable is just basically a place you store something. A function is a block of code that you might want to run multiple times. So you write it one time and call it multiple. Loops is when you're just wanting to do something for the next 10, for I equals 1 through 10, do the following. And file IO, reading in files, writing out files. A couple examples of this with a simple loop. You can use the while command. While something, do the following. And what this, how this actually breaks down is it's while read IPs from the file ips.txt, how it's redirected at the end there, do nmap -- open of that IP. So what this is doing is supposedly you have a file of IPs called ips.txt, and this is going to loop over that file and run nmap one IP at a time. Is this something you'd ever want to do? Probably not, but it does illustrate a couple different things. One, a while loop that is reading from a file, and how you can use variables from what you've read in a command inside of it. As you see there, the while read -r IP. The IP part there is what's being read in. That's the variable, and it's so you can reference later as the $IP. There's different ways you can do this. There's older ways where you can do like backticks and run a command. This is a better way to do it because I have seen people do like while cat a file, then do something. While that works, this is the more proper way to do it that is less prone to error. Oh, and the the less than symbol there just as a redirection. Redirect this file into this loop. So that's where it's reading from. There's a number of different things in there to be aware of, but like that would break if there was solder notation in there. Would it? Actually, no, it wouldn't. That wouldn't break on solder notation. But there are some other, like if you had comments or blank lines, it would have broken. But here, let's go ahead and jump into something a little different, like you're wanting to extract some information out of a command that you just ran. The command that we're running is called nmap, and we're just giving a gmap output, and we're redirecting all the output, the standard out and all that, just to dev null there. But we do want to save the output as a temporary file. The first thing you want to do is, you'll come across many times you're just wanting to make a temporary file for whatever reason in a bash script. The proper way to do that is with the mktemp. It always by default goes to /temp and then makes a random string that it stores data into. Why /temp is good is on system reboot, you erase everything in there. You can overload that and override that and say where you want to store it at and everything. But it also makes sure that there's no race conditions, that there's no collision of host or file name, things of that nature. But yeah, so we're using make temp to make a temporary file. The target is being read in as $1 from the command line. Any argument you're passing to your system or to your function will come in as a series of arguments. $1 being the first one, $2, $3, $4 down the line. Just be aware of that. So here we read in our target from the command line. We make a temporary file. We run nmap, outputting to that temporary file on the target. All right, we've done that. So now we're going to echo out the open ports on the target. So we're going to grep through that temporary file. So grep for ports on that temporary file. In there, we're going to go through a series of things that try to find lines that match open. And then we're going to do some seg, which is string editor, to strip out the ports, colon, space. We're cleaning all of it up. Ultimately, all of this does is it strings it down just to a list of ports. It strips out everything else out of that line that comes out of gmap or nmap in the greppable format. Grep is just GNU regular expression, so it goes in and you can match on strings. It's a search function. Set is string editor. TR is truncate or translate. Grep again and awk. You can use awk to, you might have seen cut or things of that nature in the past as well. It's just another way to break up a string based on a delimiter. In this case, the delimiter is a slash to print out one value of it. So this is going to go through and spit out a list of ports that was on that target. Again, are you likely ever to do this particular function anywhere? No, but it illustrates the kind of things you can do with it as well. And at the end, we're just going to go into remove the temp file because we don't need it anymore. Now, if you wanted to do that a different way, you could absolutely do that whole thing. The this grep part down here, you can do it all in awk. I'm not going to step through all of that, but awk itself is almost a pseudo scripting language in of itself, much like sed is. But if you really want to go down the rabbit hole on awk and sed, be my guest. I typically don't go nowhere near this complex with it. I tend to chain commands together like I did here just to get the result I want. All right. Let me see. Anything else here? Okay. So, as I said before, one of the benefits of having sort of the scripting automation going is that you can log everything and make sure you're covering your assets and stuff like that. Make sure that you get to the end of your engagement or end of whatever and you have all the data that you need. One of the easiest things I do is the T command. You can, whatever command you're running, in this case, who is on some domain, you do a vertical pipe, space, T, and then the file that you want to write it to. What that does, it takes every standard out, anything that goes to standard out from that command, it writes to this file. You could easily do this as well with a greater than symbol, which would say redirect. But at that point, you're not seeing any output. It's going directly to that file. In this case, you're still seeing what it is outputting to the screen, and it's logging it to a file. It's sort of a T-junction. It says, okay, whatever's coming out of standard out, throw it to the screen and to this file. So that way you have both, you get to see it if you want to screenshot it right then, but you also have a backup file of it as well. Typically, I just do a T space -A and then the file name in there. That way, the -A just says append. That way I don't accidentally overwrite something. I just always append to the end of whatever file I'm doing. Here again, just a variable called domain, what the log directory is. I'm substituting those in down here, as you can see. Make directory is something that is useful as well. It allows you to make a directory, of course. But if you have a long list of subdirectories, let's say like it's logs and then March and then 2025, each one of these is a subdirectory in there, and you don't know if all of those, if that entire hierarchy exists, you can do make dir -p and then the full path. And what that does is if any of the parent subdirectories don't exist, it makes sure that they do exist. It goes ahead and does make dir on those as well. Then it finally makes the final one. That way, I've had times where I'm trying to log out or write something out to a subdirectory and a subdirectory, and it doesn't exist yet, so it errors out. By always just making sure you do a make dir -p on the directory. It's not going to do anything if it already exists, but if it doesn't exist, then it will go ahead and make it. Just a little lesson learned there. All right. Tracking everything you type on purpose. Okay. So, this is a little script I wrote, a little part I wrote as part of my bash RC file. In bash, there are some master config files. One of them is a .bash RC, a .bash profile. There's a few others in there that allow you to specify how you want your environment to run. And typically in there, there's a section on the history files and things of that nature. What I did here is I took this section here and I threw it in there so that it allows me to easily log whatever commands was being run or whatnot inside of either a tmux or a screen session. Tmux and screen session and screen are both terminal multiplexers. It allows you to run multiple sessions inside the same terminal effectively. So it's very useful if you have like a long running process that you don't want to monitor it all the time. You can run it within a screen session, exit out, and then later go back and check on it. For me, it's very handy if I'm SSH'd into a system that I might not have a stable connection on. I'll start a screen session there, run my command or commands in that, and then that way, if I lose my connection, I don't lose the command. If I didn't have it in a screen session, it would just terminate and I lose any output or whatnot. But as it is in a screen session, I'll be able to SSH back in, jump back in there, and have all the output again. That's just a little aside on screen. Tmux is the same concept, just a different version of it. So in here, what I'm doing is, here's a couple if statements inside of bash that you can take into account now. So if $tmux exists, that is only a variable that exists if you're inside of a tmux session. If you're inside of a tmux session, then this is going to return true. Then it comes in here and I'm going to say I want my session name to be whatever the tmux session name is. By default, you can assign it a name or it picks a random set of characters for it. But whatever that name is, it grabs that session name, and then I set my history file. History file is where all your commands get written to after you run them, so you have a history log of commands you ran. I'm setting it to whatever my home directory is, .bash history tmux, and then the session name. This way, every tmux session or screen session I have has its own history file. That way I can go back and look at each individual one later on. They don't overlap with each other. They're not colliding with each other. I don't have to piece back through various history files and figure out whose is what. I have them all well labeled, well named. Same thing I did for tmux. For screen is if the $STY variable exists, you're inside of a screen session, GNU screen. Same thing here. I'm just going in and grabbing what the session name is. That's easily done with a little weird command substitution there out of bash. Grab out the session name. I'm writing it out, and then export. And then if I'm not in tmux or screen, I'm just writing out my history file being standard .bash history like it typically is. This way, if I'm ever on my system, I look in my home directory at .bash history star. The .bash history is my primary that I'm writing to if I'm not in a session of some kind. And each of my tmux and screen sessions are in their own little history files as well. Not everybody needs this. I don't always need this, but it is a handy little thing to do sometimes if you're wanting to write out history files to different locations. I actually have a different solution that I use now, but this was what I used for quite a while. Speaking of history files, there's a couple variables that can be handy when configuring your history files for use. Inside of your bashrc file, you can set up history control, history ignore. These are used whether or not you want to ignore repeated commands or commands that have spaces in front of them, stuff like that. Sometimes those are logged, sometimes they're not, depending on what you have set here. History size is how many history lines to store. History file size is how many to write out to the file. History time format is if you want to have in your history file, or when you type history on the command line, to know when a command was ran. By default, it doesn't tell you. You can do a history time format and specify out month, day, year, hour, minute, second, or some other combination as you see fit. And that will allow you to be able to see that when you're typing history on the command line. Now you can see when you ran a particular command. This is a particular use for me when I'm doing an engagement and a customer comes back to me and says, hey, what were you doing around about 1 o'clock today? Because we see some weird activity on XYZ system. So I can go back and look at my history and see what I was running around about that time and see what might have been applying to that, what might have been affecting it. And then, of course, history append. That allows you to make sure everything gets written out to the history file appropriately. All right, something else just to do as you're going through with the history file. If the history file doesn't exist, touch. All touch does is it makes a 0-byte file named whatever you specify. That way it makes sure that the file exists. It's okay to be an empty file because it will be appended to later. But right now you just want to make sure the file exists on the file system. There's an inode and a little object that's created, but still. You want to make sure that it is properly secured. chmod is change mod to 600, which is only you can read and write to it, and no one else can read or write, and no one has execute permissions on it. That way it's a nice secure file that no one else can happen. Like if you're administrator and somebody else jumps on the system, or your root, somebody jumps on there, they can't read your history file. The execute bit isn't in there. So that if you accidentally write something executable in there, which obviously you are, it's a history file, you can't execute it directly from there. It helps some weird security issues in there of that. And the command up here is if not -f is that is a valid file. If it is not a valid file, then you make the file. If it is a valid file, it skips over and moves on. Taking everything you tracking everything you type on purpose again. This is just a few other things I've found that helps me log as I go. There's a history sync command that is a part of that you can set up. Well, that's what I use at least. And I just tell it to do history -a, -n, and -w. -n says make sure you append any new entries to the history file. -n says read updates from other sessions, and -w is write the complete merged history as it's going. That way you don't, if you kind of just Control-C out of your SSH session, you don't lose any commands, things of that nature. Everything's written as you go. So then if prompt command is a command that is issued when the prompt is displayed. I believe it is the way it goes. Yeah, when your like hash sign or dollar sign prompt is displayed, it calls a prompt command as well, just to know what else it needs to do. And all I'm doing is I'm having it run history sync command. That way, on every command, it makes sure all of this is flushed, appended, and so forth, so that I don't lose anything as I go. If there are things that are already in there, I just append it to the end. So I'm just resetting prompt command to be prompt command and then semicolon and then the next command. In Bash, you can chain commands together by putting a semicolon in between them. That way you can run multiple commands in the same window. They're done sequentially, but you don't have to type them out one per line. All right, I know a bunch of this is boring, so let's go ahead and get into a little something different. Let's go ahead and work on a little automation of going from like an nmap to a metasploit sort of a transition here, a little automation you might have. All right, so in this one, we're going to use metasploit, bash, and nmap, or technically nmap output. We're making use of a known good word list. We're going to pull targets out of a gnmap file, and then we're going to process them with metasploit. So I lied. Not everything in here is going to be bash. We do have some Ruby in here. This is just for a metasploit RC file. You can write them differently than this. I just like using the Ruby for it because it gives me a little more flexibility. You don't have to. But all this is doing is just to step through it. We're not really talking about the Ruby here, but still, I'm just specifying who the what the module is. In this case, we're doing the auxiliary MS SQL login script, where I'm specifying the user file to being wherever my MS SQL users file is, and a password's same thing. And my rhost file is coming from a file that I'm storing in /root/1433.txt. Where that file's coming from, we'll talk about in a minute, but all this is just some variables that are set up. And then inside of the self run single, you don't have to do the self.run single. You can just do run single. There's some weird little nuance there, but for me, I always put the self in there. So I just use whatever module it is. I set the user file, set the pass file, set the rhost file to whatever specified there. Then I run it. So this allows me to, anytime I have a 1433.txt file inside of root, I can run this RC file, and it's automatically going to pull in my usernames, my passwords, use the proper module, and run. A variant on this, I have a very elaborate setup where I run my nmap scripts or nmap scans. I parse all that out into a series of files similar to this root 1433.txt based on the port number. And then I have a whole subdirectory of these RC files that know what file to trigger off of. And I just go through and run them in mass. So it goes through and identifies if that file exists. If so, then it goes ahead and kicks off this module. So this is something I actually use a very similar version to. Not exactly, but the same concept applies. So how are we going to do this? Scrolling on down through there. This is some more logging you can do inside of an RC file, inside of the Ruby part of the RC file. You can specify a T directory, what the path is, the T log path if you wanted to. You can spool is a command within Metasploit that allows you to log to a file. So I'm just saying here, spool out to whatever that log path is. And then I'm going to run, when I'm done processing everything else, then I turn spool off. So all of this, those top 3 lines would be done before the module path up here, most likely, or before the self run at least. Then once that's done, I do the spool off at the bottom. That way I'm logging everything as I'm typing it in, or it's typed in and I have the output of it. Yes, I love logging. I've been bitten by not having the right logs way too many times. So now I'm a little OCD about actually logging everything. Going back to how am I building that file, and now for parsing the nmap output, I'm just specifying my output file is going to be root 1433.txt. I'm making sure it's truncated. In Bash, you can always just do the greater than. If there's nothing before it, just do a greater than space and a file name, and that will zero out that file. It'll truncate it down to 0 bytes. It'll empty it out. So that way you're making sure everything's cleaned out. There's nothing in there. That's just in case I run it multiple times and I don't want to accidentally keep appending to it or whatnot, or there's some other issue. So I'm emptying out the file. Now I'm finding starting in my local directory, find all the asterisk.gnmap files. Maybe I'm finding multiple of these. Maybe I'm finding maybe I ran multiple different scripts and I have a bunch of different ones out there. Maybe I ran it where I targeted each individual IP and it wrote out a gnmap file. Whatever scenario, I might have multiple. This way I'm finding all of them. Find just says starting in the local directory, go recursively for anything that matches this regex of star.gnmap. So anything.gnmap. If I find that, pipe, it takes the pipe here says take whatever I get out of here and feed it sequentially over to the next command. In this case, yeah, reading it in. For this, I'm now doing while read file do. I'm grepping for this line 1433 open TCP out of whatever files fed over here, because that is going to be a file name. So for each file name that gets sent this way, it's being filled in here. It's grepping for that. And if it matches that, it then it then runs awk and prints out the second value. The second value of a gnmap file is your IP. Then it concats the less than or greater than is a concatenate symbol. It concatenates that to the output file. A lot going on in there. All it's doing is it's looping over and finding every gnmap file, looking through those gnmap files for lines that have 1433 open TCP in them. Then it's pulling the second value of each of those lines, which should be an IP, and throwing those into a file. This whole thing is just building a file called empty file or output file called root 1433.txt of IPs that should have 1433 open on it. All right, that's enough. The sort-u-o. That says sort-u, do a unique sort on the file, make sure that there's no duplicates in there. Maybe there was, I might have scanned the same system twice. -o just says you can write it back out to the same file you read it from. So I'm not making a temp file here. So I'm just sorting the file and writing it back to itself. So at this point, I have an nmap scan that creates or scans that create multiple or one or more gnmap file. I'm running this script that I just had here. It's building my file of root 1433.txt. I have my RC file that I wrote earlier. That comes down, and then I have just something that I'm just running that metasploit RC file, and that's writing out to some directory or some file there. So this is a realistic process that I actively use something very similar to. Like I said, I have a automation that goes through and takes in whatever the target list the customer provided me. It runs a bunch of nmap scripts against those, trying to find various instances, various services that I might be interested in, throws all those into a directory. I then have a parsing script that goes through and parses each one of those out into files of appropriate port, where that file contains only the IPs that had that port open. Then I go through and loop over all my RC files that runs and collects various data about those ports, and that all outputs out to a file. This is something I can kick off as soon as I start an engagement. I do a few other record keeping things. Once I feel I'm ready to start doing service and port scans, I go ahead and kick this off in its own screen session. And then in another session, then I'm doing man-in-the-middle attacks. I'm doing various other things. And at some point later, I'll come after lunch or by the end of the day, I'll jump back over to that screen session, see how this is going. Maybe it's done. If it is, then I'll go start looking through all the output that these metasploit RC files created. And I'm looking in there for typically anything that has a plus sign in the string, because that's usually how metasploit flags if it's a successful hit or a finding or something of that nature. So this same flow is something I do as part of a regular automation I do on engagements. All right, let's see here. How much farther we have? Not too much farther. We'll step through this real quick here. That's the same thing that it's doing there. Build the list out to a directory, make the log directory, run MSF console, -q is quite, -r is RC file, and I'm teeing the output. That's where all that's coming together at. The prompt, I'm not going to spend too much time on this. There's a lot of discussion on what your bash prompt should look like. Typically mine, I like to have something very visible for me. Like I like to know the date and time. I like to know if I'm in a screen session or not and what screen session it is. I like to know if I have a Kerberos TGT ticket exported. If so, what is it? Am I in a Git directory? If so, I need to know what I'm in there. I don't have all of this on the screen at any given time. These are dynamic and they will pop up as I'm in one of these environments. But this kind of thing is what I like to have on my prompt, just so at any glance down, if I jump into a screen session, I jump into another terminal, this will tell me what's going on right where I'm at. Do I have something exported that I can use for Kerberos authentication? Am I in a screen session? If so, I don't want to start a new one inside of there. And things of that nature. Also tells you who you are, where it's running, and all that. A lot of stuff on here. You can set up the date time with all the funky little color codes. The /E is escape. Bracket 36M is a color code. /D is a date symbol for a month, day, year, hour, minute, second. A lot that can go into there. There's whole wikis out there on how all these escape codes and what can go into a bash prompt and all that. We're not going to spend too much time on this. I'm running short on time, so let's go ahead and step through this a little bit faster here. Let me step back. So this one was if I'm in a TMUG session, like I did before, I go ahead and I set the session name in my prompt to be appropriate. If I'm in a screen session, same thing. If I see that KRB5CC name is exported, then I have a TGT ticket out there. If I do the whole Git repo thing to know if I'm in a Git repo and if it's up to date or not. And then at the end, where each of those is stored as a variable, I now just set my PS1, that is your bash prompt, to be the date time, the session, the Kerberos ticket, the Git repo, and then all your standard stuff here, a new line, and then who the user is at the host, and what's the working directory, and then if I'm on a $ or a hash prompt session. Then bash command just calls the function that builds all of this, basically. That's the custom pen test prompt. Builds all of that so that this is all displayed at every time I get a new shell prompt. You see, some people have over here, I got the timestamp and current directory in my prompt. Good, good. I always have that handy. For engagements, do you use TMUX exclusively? I use GNU Screen. I don't use TMUX. Why? I'm gray. I'm old. Screen existed first. I got stuck on Screen back in college, and I've been using it ever since. TMUX has its is almost identical for most use. I just like Screen better, and Screen is automatically on most Unix systems as well. Terminator, yeah. So of all the TMUG, Screen, all of those, to each their own. I'm not going to start the whole flame war between Vim and Nano and Emacs and all of that. Use what makes you happy. Use what you're familiar with, what you can make use out of. Use that. I know Screen well. I use Screen a lot. I have a bunch of stuff in here for TMUX because I have coworkers that use TMUX. That's the only reason I have it in there. Do you have a repo with some of your most useful scripts? Yes, and I will try to share that here at the end of this. I'm out on GitHub. You should be able to find a lot of my stuff out there on github.com/Tatanus, Tatanus. It's a name I've had all the way since high school. It comes back to some old role-playing game, and I started doing all my emails with Tatanus in it, and I've just stuck with it ever since. So yeah, my GitHub is github.com/Tatanus, Tatanus. I have a lot of various code out there. I'm in the process of updating a bunch of my bash stuff in there now, reconsolidating and cleaning up. But you'll find a lot of stuff out there, as well as my preferred style guide that I wrote. Okay, going on to a little bit here. Let's finish up. Do you really need to script? Yes? No? Is there an absolute need? No. Does it make your job potentially so much easier at times? Yes. Does it help with consistency? Make sure you have all your logging done. Make sure you have done the same thing time after time. Make sure that you don't get old and forget the next command to run. It's already scripted up for you. So it comes in handy, yes. And I absolutely love it, and I promote it to everybody, but no, it doesn't. I know I say short answer, yes. The real answer is no, it's not required, but it does make a lot of things a lot easier. The role of AI. Oh. Can you use AI to generate scripts? Yes. Are they going to work? Probably not. Do you need to know how to script up those things yourself in Bash in order to fix them? Probably. So, Bash and AI, or AI in any coding right now, is great for an idea. If you already have fluency in that scripting or programming language, you can have AI build you a framework for it, and then you can go in and tweak it and get it to work. Very rarely, anything more than like a 5-line bash script is it going to give me something that works right out of the box. I've used Claude, I've used ChatGPT, I've used various other ones, Olama. None of them are really great at this. They can get you close. Sometimes you'll be lucky and it will work, but don't count on it. You still need to have your own scripting abilities to take what it provides you and then fix it or get it to work exactly the way you want. Does it save you some time potentially on crafting up a bunch of things quickly for you, fixing formatting, all that? Sure. And I do use it for some things, but as a whole, I don't use it to write my scripts for me. I write it to write some comments for me, maybe clean up some things in there for me. But as a whole, you still need to know how to do the scripting yourself. Tips for blending AI. Yeah, start with, like I said, start letting it generate it, but then you need to verify and debug it, develop strong fundamentals in Bash scripting yourself, and then learn how to balance your own abilities with what AI can provide you, and then work from there. Efficiency, accuracy, automation takes care of a lot of efficiency and accuracy, assuming it was written accurately to begin with. You're going to get out what you put into it, but assuming you wrote your automation accurately, yeah. What solutions do you recommend deleting bash entries from your history in a production environment? The idea is to save them for the record, but not have them visible to those with access to the machine. Ideally, okay, the question is that somebody just popped over here is, how do you clean your bash history so that people who have access to the system can't read them? I'm going to play devil's advocate and a little annoying here, but ideally, you're running things as your own user. Therefore, they should only exist in your bash history. Therefore, others shouldn't have access to them. However, if you're running as root, then you're running as root, and it doesn't matter if somebody has access to read it because they have root as well at that point. Therefore, they can reproduce anything. So my suggestion is to make sure you have proper user confinement, user roles and responsibilities, and you're not running things at a higher level than absolutely need to be. Don't be sharing accounts. But if you want to erase a bash history, you can. There's I forget the command off the top of my head, but there's a truncate command you can give to bash or to history that will flush it, things of that nature. Like I said before, some of the configuration options to it, if you don't want it to show up in the history, you can put a space in front of the command. Sometimes that works. Yeah, somebody type down there history-c history-w. Exactly. That'll work. I couldn't remember what the flags were off the top of my head. Thank you for that. Um, but yes. Um, so realistically, that's your only solution. I mean, yes, you can delete your history file and it will recreate it, but that has its own things that may go wrong if you have other people using it at the exact same time. But yeah, clearing and writing the new history might have similar issues. Um, Typically, you shouldn't be that concerned about because you shouldn't really be running anything that you're concerned other people are going to read that they will have access to read. But we can discuss that at some other point as well. Logging, structured. How do I suggest growing your habit? Practice regularly. Write. Scripts for everything. I'm constantly writing new scripts. I'm writing scripts that help me write other scripts at this point. So, and then build a library of various things that you've collected over time. Questions? Sorry about that. And in doing so, I'll go ahead and throw up my contact information on there. And like I said before, my name is Adam Compton. I'm here at TrustedSec. My Twitter handle is @Titanus. Let me see if I can pull up in a different window here somewhere. Can I send a message out there? I don't know if I can send something out there or not. But yeah, you can find me out on GitHub at /Titanus there as well. In there, I should have a bash style guide, which is the one I use for my own stuff, just so I don't forget it over time. I threw it up there. I have a bash setup repo on there, which I use to set up my bash environments every time I jump onto. Yeah, bash setup is a great one there as well. That's one I use that has all my dot files in it, a bunch of automation in there. There's a combined history script in there, a bunch of stuff in there that I use on my day-to-day use. That's in there as well. There's other ones out there as well for. I have a scripts one, which has a bunch of random Python and or bash scripts in there that I've used over time. I have a few others that are in the process of being updated and pushed back up there, which are going to be scripts that dedicated just to my pen testing and things of that nature. I'm in the flux of trying to shift how my framework works and all that, so I don't have those up there yet, but monitor that space and it will be back up there. And yeah, there's a lot of stuff I'm pushing up there. Over the next, I don't know, a couple months, you should see pen test setup go up there. It's similar to my bash setup that is used to set up my pen test environment on top of my bash that allows me to automate a bunch of stuff, installs all the tools I want, all that stuff. Pen test validation that allows me to validate findings using a number of different tools automatedly from Nmap and Nessus and all kind of stuff. Bunch of stuff up there. Keep that up in mind as you're going through it, but don't just rely on me. I have a very particular way I like to do scripting and bash, but that isn't going to be for everyone. Just the things I have in there, like if you read my style guide, you'll see a lot of my gotchas I throw in there, things that I like to script up in there, things that are like you should do set dash u o pipe fail in there. That way it'll warn you if you have undeclared variables that are being, if you're using variables that haven't been properly declared and it's going to fail properly and all that. You can set your trap conditions and all that. A bunch of stuff I have in my style guide. Take a look at that. Google has an amazing style guide. It's huge. I kind of trimmed down just the relevant parts and put it in mine as well as some other stuff in there. But yeah, so I'm going to take a breath and if anybody has any questions, comments, or anything, let me know, and I'd be happy to try to answer a few more. I think I answered everything over there already that's come across. If I haven't, I apologize. But yeah. Yes, I've used Exegol. Um, and I do and don't like it at the same time. I do like it that it has a lot of automation in there, and I've actually borrowed the concept, reworked it to work in my environment for some of my pen test automation, how I have things set up, but it's more like it was inspired by, because I'm not 100% sure I like the way they handle some of their stuff, but I do. If you're not into writing your own full framework for doing everything, Exegol is great. I'll give you that. It has all the tools you need in there, or a lot of tools you need in there, automation on how to set it's already set up and all that. Great. I love its history, how it has the commands in there already, but yeah, it's great. I think we're getting close to the end here. I don't think Rosa had anything to say, but I do appreciate the time, everyone. Give everybody one last chance to ask any questions. I'm happy to answer a couple more here if you have any ready to go. Otherwise, appreciate everyone for stopping by. Hope you learned a little bit from my non-stop 50-mile-an-hour speaking going through all this. I do apologize for that. The video will be up on YouTube later. And yeah, thank you very much. Hope everybody has an amazing day, and go out there and write some nice scripts. Oh, and thank you. Yeah, it's been growing for a while, since I was maybe 5 years old or so. No, this time it's probably been growing for the past 20 years, and I trim it off every once in a while. But yeah, I appreciate that. Thank you. Everyone, have a great day, and I think that's it for everyone. I'm going to go ahead and